So let's talk about direct variation for a second. We can say y varies directly with x if there is some constant k that makes this equation true. Y equals kx. I'm going to rewrite this a little differently because I think this will make more sense if you see it this way. So let's divide both sides of this equation by x. X divided by x makes a 1, and 1 times k is just k. And I have this ratio y over x equals k. Where have we seen y over x before? You guys remember slope? That rise over run, that change in y over change in x. So we've seen this ratio before, so this idea of direct variation isn't anything new. It's just, I guess we're calling it something different. So this is very helpful for us because if there is a constant ratio of y to x, this is going to be true for any number of points that are on this line, which means even if we're missing a couple pieces, we should still be able to put the puzzle together. So what kind of examples or problems could we see when talking about direct variation? Well, here's two right here. Let's look at these tables for a second. Is the relationship shown between the values in each table a direct variation? So remember, direct variation means that there's some constant k where y equals kx, or we can think of k being that constant ratio of y over x. And that idea of it being constant is important. I can't have 4 different ratios of y over x. It needs to be the same ratio of y to x. So let's try, we'll call this one number 1. We'll try this one real quick. So is there some value k that is constant throughout this entire table? If that's true, I should be able to say that, remember, y equals kx. So if I'm looking at this first one here, that 10 equals some value k times 2. If I were to divide both sides by 2 here, we see that our constant k is really 5. Let's just try another one real quick. Let's switch it to blue. Over here, this ratio of 4 to 5, I could write that 4 is equal to some constant k times 5. And if I solve this for k by dividing both sides by 5, we see that, I guess this is, I'm just going to leave it as 4/5, or maybe you could write 8/10 or 80%. These are not the same. These are not the same ratio. If it's a direct variation, it needs to be constant, right? I'm looking for a constant ratio. And because it is not constant, this would be a big ol' no. Let's try the second one. I guess we'll call this one number 2. Again, I'm looking for that constant ratio of y to x. So let's check this first one. I'm going to do the second way of just writing that ratio of y to x. So 6 to 1 is 6. Let's try 12 to 2. So k would be 12 to 2, which is also 6. Let's try this third one. K here is equal to 30 to 5, which is also 6. And I'm not going to write down the last one, but if I do 42 to 7, that is also a ratio of 6. So this is a direct variation. Yes. You might also see a more kind of word problem type of question. Suppose y varies directly with x. When y equals 30, x equals 6. What is the value of y when x is 100? Well, I can do the same thing. If I know that there's some constant k that makes this true, or maybe I think of it the other way of that ratio y over x equals k, I already know one of my ratios, 30 to 6. So again, y over x means 30 over 6. I guess I can write that over here too. So that's going to be equal. It's going to be constant no matter what x and y are. So if I have a different value of y and x, and I think I'll use a different color to kind of color code this a little bit. If x is 100, what is y? Well, if I just fill in my ratio of y to x, I have this new expression. I can solve my ratio. I'm just going to do it by cross multiplying. Let me pick a different color. We'll go green. 6 times y is 6y. 100 times 30 is 3,000. And if I want to find out what y is, I could divide both sides by 6. And I end up with y equals 500. Cool, thanks.